So now that we understand what it means for a function to be one-to-one, we're now ready to go ahead and define what an inverse function is. It's called the inverse function property. A function f has an inverse function f to the negative 1 if and only if the function is one-to-one. The domain of the inverse function is the same as the range of f, and the range of the inverse function is the same as domain. And what the inverse function does, it undoes or reverses the operations of the original function. It does reverse function in reverse order. To verify algebraic that f inverse is an inverse function f, both of the following statements have to be true. If I take f inverse composed with f, I get x for all x in the domain of f, and f of f inverse of x equals x for all x in the domain of f inverse. So find the inverse function. If the function y equals f of x is one-to-one, the inverse function can be found by interchanging x and y in both the function and in the domain and range. And then you go through and you solve for y, and you replace y by f inverse of x. And what this means when I'm doing this graphically is that if I've got the graph, I'm going to pick some points on the graph to find the inverse. I'm going to switch around the x and y coordinates and use those points to graph. So the graph of a function, its inverse function, will be symmetric to the line y equals x. To find the graph of the inverse function from the graph of function, switch the x and y coordinates of each point. So for instance, here I've got my original function, 0, 1. I would switch the coordinates, 1, 0. Here I've got 1, 2, switch the coordinates, that's 2, 1. Got a point here of negative 1, half, switch it, half, negative 1. And then that gives me my inverse function. Or like on this one, here's my g function. Point is negative 0, negative 3. Switch the coordinates, that's negative 3, 0. We have one here at 1, negative 2. Switch the coordinates, it becomes negative 2, 1, and that's going to allow me to draw in the inverse g. And you always want to make sure you note that the graph of function and its inverse is symmetric with respect to the line y equals x. That's a quick way to tell if two functions are inverses of each other. So let's go back to our workbook. And let's see, we need to hop down to problem number 8. So if I'm looking at number 8, and you may want to draw this in, you go ahead and draw that y equals x line. And looking at the picture, the graphs really do look like they're symmetrical, that this is the mirror image of this across the y equals x line. Just to verify, I'm going to take a couple points. Like here, negative 2, 1. If I switch the coordinates, 1, negative 2, it's there. 0, 2, switch the points, the coordinates to 0. So it looks like this is lining up. Let's check number 9. Again, I'm going to draw on that y equals x line. So think of the solid line as one function. That's probably what g is. Dashed line is the inverse. And again, it looks like, yeah, they're symmetric with respect to the line y equals x. You can pick a point here like negative 4, 4, switch the coordinates, 4, negative 4. It's on the inverse. Let's try this next one. Again, I'm going to draw on that y equals x line. And this one doesn't seem to be working. So, because if I got, look, and I can kind of tell if I take a point here, 0, comma 2, if I switch it, I should get 2, comma 0, and that's not on the function down here. So, for 8 and 9, they do work. So, both of these are yes. They are inverse functions. Same thing for number 9. But number 10 does not work. So let's look at problems number 11 and 12. Look at problem number 11. The graph of functions given, graph the inverse function, and find the following. So we want to graph the inverse function, and it looks like we want to find, actually we can already find the domain of f and the range of f, because we already have it drawn. So squishing this down, so flatten this out, I get -4 to 1 for the domain. For the range, flattening it out, I get -2 to 4. Now for the domain and range, so even without drawing the inverse function, what should be true is that the domain and range of the inverse function is going to be swapped around. So the domain of f inverse should be -2, comma 4, and the range should be -4, comma 1. And that makes sense because you're switching around the x and y values to get the inverse. So the domain is my x values, the range are my y values, I'm switching around. That's why the domain and range are flipped around. Let's verify that when we graph the inverse. Now, to me, the easiest way to do this is pick some points. So like here, I've got -4, comma -2. I want to switch those coordinates around. That gives me -2, comma 4. Let's pick this next one. We have -3, comma 1. So again, I want to switch around the x and y coordinates. That gives me 1, -3. My next point here is -1, comma 2. Again, I'm going to switch around the x and y coordinates. That gives me 2, comma -1. And then finally, I've got this point up here, which is 1, comma 4. I'm going to switch around the coordinate. That gave me 4, comma 1. So now I just connect the dots. And that's my graph for my inverse. So this would be F inverse. Keep in mind with that notation, that means an inverse function. So when we say f to negative 1, that's not equal to 1 over f. This is just function notation. And now notice, if I were to look at the domain here, starts at negative 2, ends at 4. Range starts at negative 4, ends at 1. So notice that matches. So let's try G. And this time I'm going to draw the inverse function first. So I'm looking at G here. I've got 4, 0, comma 4. That becomes 4, 0. Two comma 0 becomes 0, 2. And let's grab one more point. So I'm going to use this one here. This is 1 comma 3. That comes 3 comma 1. So my graph is curving like this. Now look at the domain of G. Starts at 0, ends at 2. Oops, a square bracket, my bad on that one. That should be the range of G inverse. And I should have labeled this G, my bad. So this should be G inverse. And notice that range starts at 0, ends at 2. So I'm just going to mark that down here. The range of G starts at 0, ends at 4. That should be the domain of G inverse. So notice it starts at 0, ends at 4.